Hello, everybody, and welcome back to Unit 5 Physical Behavior of Matter, where we will be specifically focusing on gases. So, last time we talked about the gas laws and we discussed five different types of gas laws. Today, we'll be looking at how we can perform calculations using the equations for those gas laws. And this is going to be the last part for this chapter. So, you guys will be able to calculate the different gas variables using the correct gas law, whatever we have to use for any specific given question. So let's quickly take a moment to review the five different gas laws, actually all of the gas laws that we discussed in this chapter. So the first one that we talked about is the ideal gas law, which is PV equals nRT. The second law was Boyle's law, which is P1V1 equals P2V2. And remember, pressure and volume are inversely related according to Boyle's law. Then we had Charles' law, which said that volume and temperature are directly related. So the equation was V1 over T1 equals V2 over T2. Then we had the Gay-Lussac law, which said that the pressure and temperature are directly related as well. So the equation is P1 over T1 equals P2 over T2. Then we had the combined gas law, which basically just combined the Boyle's, Charles, and Gay-Lussac law. And it gave us the equation P1V1 over T1 equals P2V2 over T2. And just a quick reminder that this equation, the equation for the combined gas law, is also given in your reference table packet in table T, which is the last page in your packet. And finally, we talked about the Avogadro's law, which said that the volume of any gas and its number of moles or the amount of molecules that it has are directly related to each other as well. And then just a quick reminder, what this law specifically said that if we have 22.4 liters of any gas, then those 22.4 liters contains 6.02 times 10 to the power of 23 molecules, which is equal to 1 mole of that gas. So when we are given a question related to gases, the first thing that we want to figure out is which gas law are we going to use. And to do that, what we want to do is we want to look at the quantities or the variables that are given. So if, let's say, we are only given the one quantity or one measurement for each variable, which means you only see one number for pressure, one number for volume, one number for temperature, and stuff like that, then that identifies that you're going to use the ideal gas law, because ideal gas law is the only law out of the six laws that we discussed that only has one quantity for each variable. Because remember, all the other laws have like the ones and the twos, because we normally have two quantities or two measurements for whatever variable we are looking at. So, for example, let's look at a question like this. In this question, it's asking for the number of moles. We are given one number or one quantity for the volume. We are given one number for the temperature. We are given one number only for the pressure. And then we are supposed to find the number of moles. And remember, because it's the ideal gas law, we'll also use the gas constant, but that's something to do later. So this is how we know that this is where we have to use the ideal gas law. Now, let's say you have a question where you see two numbers for the pressure, volume, temperature, anything like that, that identifies that you cannot use the ideal gas law here. And then you have to figure out which of the other five laws are you going to use. So let's say you see more than one measurement for each variable, and you are only given the pressure and the volume for that specific gas. You're not given any other thing. It's just the pressure and the volume. And they have more than one measurement. So you see two different numbers for pressures, you see two different numbers for volume, then that is when we will be using the Boyle's law. Because remember, Boyle's law is P1V1 equals P2V2. So for example, a question like this. We have a gas that occupies 12.3 liters. So that 12.3 liters is the first volume. And then that is at a pressure 40.0 millimeters of mercury. And then the question is asking what is the volume when the pressure is increased to 60 millimeters of mercury. So we have one measurement or one quantity for a volume. We've got one quantity for pressure. Then we've got another pressure, and we are supposed to find the second quantity for, or the second number for the pressure. Okay. Now let's say once again, we are given a question where we see more than one measurements for the variables, and we are only given temperature and volume. That's what will indicate that we are going to be using Charles' law, because Charles' law says that volume and temperature are directly related. For example, a question like this, we are supposed to calculate the decrease in temperature when 2 liters of any gas at 20 degrees Celsius is compressed to 1 liter. So here we see uh, the first volume, then we see the first temperature, and then we see another volume, and we are supposed to find the second temperature. So once again, we are given more than one measurements for the variables, and now we have the pressure, volume, and also the temperature. So whenever you see all three of them, and or they have like different they have more than one measurements or more than one quantities, that's when we'll be using the combined gas law. For example, a question like this, we have a sample of neon gas that is occupying 4.61 liters, which is the first volume. Then we see 2.83 atmosphere, that's the first pressure. And this is at 277 Kelvin, that is the first temperature. Now the question is asking what will be the pressure of the gas when it's at 8.3 liters, which is the second volume, and it's at 293 Kelvin, which is the second temperature. We are supposed to find the second pressure. So that's where we'll use P1 V1 over T1 equals P2 V2 over T2, the combined gas law. Finally, once again, if you're given more than one measurement, and now we see the number of moles and the volume, what do we do in that case? Well, that's when they'll use the Avogadro's law. For example, a question like this. How many moles of a gas were present in a 67.2 liter sample if only 11.2 of the sample is left now? So we had a 67.2 liter, and then we had an 11.2 liter, which was the second volume. So volume 1, volume 2, and we're supposed to find the number of moles that we had in the beginning of the experiment, not at the end. So make sure that you guys are paying attention to the questions. Make sure that you can differentiate between which number is the old number and which number is the new number. So the old numbers are ones, the new numbers are the twos. So let's look at how can we work on this question. So this is the same question that we looked at for Boyle's law. We see 12.3 liters of this gas, which is the first volume that we are given. Then we see 40 millimeters of mercury, which is the first pressure. We see 60 millimeters of mercury, which is the second pressure or the new pressure. And we are supposed to find the new volume of this gas. So here we have the equation for Boyle's law, P1 V1 equals P2 V2. We can just go ahead and substitute the numbers in the equation. We put in our first pressure and volume, or old pressure and volume, and then we put our new pressure, and we are supposed to find the new volume. So the same old thing. When we have to solve for the V2, we want to get rid of that 60 millimeters of mercury. So we can just go ahead and divide that on both sides. When we do that, the 60 millimeters of mercury on the right-hand side cancel out, and we can just go ahead and punch in these numbers in the calculator and get our answer. So that turns out to be 8.2 liters. So here's the question that we looked at for Charles' law. We see our first volume, we see the first temperature, and then we say it says that the gas was compressed. But one thing to notice here is that the temperature that's given to us is in degrees Celsius. And remember, we discussed in the previous chapter, in the previous topic, I mean, that the temperature of gases is always supposed to be in Kelvin. So we have to convert this degrees Celsius temperature into Kelvin. So very simply, whenever we convert from degrees Celsius to Kelvin, just add 273. So that gives us a temperature of 293 Kelvin. And then we have our second volume. We are looking for the second temperature, the decrease in temperature, or the new temperature that we had. So this is the equation for Charles' law. We just go ahead and punch in all of the numbers. And then, now here's the thing, and please pay attention to this. Whenever we see an arrangement like this, where we have things in the division and we are supposed to work or find something from that equation. For example, right now we are trying to find the T2. The easiest way to do problems like this is cross multiplication. So this is what we call cross multiplication, which means the 2 liters is going to multiply with T2, and then the 293 Kelvin is going to multiply with 1 liter. So this is what it's going to look like. Okay, and now we still want to solve for the T2. So we will bring that 2 liter to the other side of the equation, and to do that, we can just go ahead and divide the 2 liters on both sides. The 2 liters on the left hand side is going to cancel out, and we can just go ahead solve for this part, and there you go. Our final answer is going to be 146.5 Kelvin. Okay, next up we have the question for the combined gas law, and the same question that we looked at before. We've got our first volume, the first pressure, and the first temperature, and then we are supposed to find what the final pressure of this thing was when we changed the volume to 8.3 and we changed the temperature to 293 Kelvin. So here's the equation for the combined gas law, which we also have in table T. We can just go ahead and plug in all of the numbers, all of the values that are given in the question, and now we are supposed to find P2. So once again, because we have things in the division, we can go ahead and do the cross multiplication. So when we do the cross multiplication, we get the 2.83 atmosphere times 4.61 liters multiplying with the 293 Kelvin. And that is going to equal the P2 and 8.3 liters multiplying with the 277 Kelvin. So basically the numerator of one thing multiplies with the denominator of the other side, and the numerator of that other side multiplies with the denominator of the first side. That's how cross multiplication basically works. So now once again, we have to solve for P2, which means we want to get rid of 8.3 liters and 277 Kelvin on this side and want to bring that to the other side. So we can just go ahead and divide the 8.3 liters times 277 on both sides. So that is going to cancel out these two numbers on the right hand side, and then we just put these numbers on the left hand side in the calculator, and that's how we get P2 equals to 1.66 atmosphere. Finally, let's look at our question for Avogadro's law. This is asking how many moles of a gas were present in a 67.2 liter sample if only 11.2 liter of this sample is left now. So we are given two different volumes. We are given the first volume and we are given the final or the new volume. And we're supposed to find the first number of moles, what we had initially, not what we had at the end. Now, the problem with this question is that we cannot use the equation for Avogadro's law until we know how many moles of this gas do we have right now, or what were the new moles of this gas, which is not given in the question. And the reason why it's not given, because they expect you guys to know how to figure that out. So a quick review. Avogadro's law say that 22.4 liters of any gas has 6.02 times 10 to the power of 23 molecules, and that equals 1 mole. So now if you look at this new, because we are trying to find the new number of moles, right? So we look at the new volume that we have. So this new volume is 11.2 liters, which is half of 22.4 liters. So remember, Avogadro's law said that volume and number of moles, or the number of molecules, are directly proportional to each other, which means if we increase the volume, the number of moles increase. If we decrease the volume, the number of moles also decrease. So now that we are decreasing this volume, we are making it like 1/2. The number of moles, it's also going to decrease to 1/2. So if 22.4 liters is equal to 1 mole, then this volume that we have in this question, the 11.2 liters, is going to equal to 0.5 moles. Okay, and there you go. That is our new number of moles. Okay, the N2. So now we can go ahead and plug in these numbers into the equation for Avogadro's law. And this is what that is going to look like. So we have to solve for n1. My apologies, that is supposed to be n1. So when we solve for n1, we can just simply go ahead do the cross multiplication again. So 67.2 liters is going to multiply with 0.5 moles, and then 11.2 liters is going to multiply with n1. So now we want to get rid of the 11.2 liters, like on the left hand side, and we want it on the right hand side, and we want to bring that to the left hand side. So we can go ahead and divide both sides by 11.2 liters. It is going to cancel out on the right hand side, and then we just simply solve for this whole thing on the left hand side, punch that into the calculator, and there you go. The number of moles that we had initially, or the old number of moles, turns out to be 3 moles, which makes sense because remember, the V1 is also larger and then V2 is smaller, which means the number of moles were also larger in the beginning, and then the new number of moles were smaller. Alrighty, guys, so that was it for this chapter, and I'm gonna peace out with that, and we'll see you in the next one.